Okay, so I thought I would do a quick video on just an overview of the software that I've written to drive Nova. Quick little background, I'm a web developer by profession, going on 26 years actually, but C is new to me, as is Arduino and electronics and robotics and the like. So please refrain from commenting on my code. I could already understand where it could be improved, and I'll probably talk about that going through this. My videos are also unscripted, so pardon me if I'm a little all over the place. I'll try not to. All right, so this video is just meant to be an overview. I won't really go into detail about any of the sections of it. I'm just going to describe on how I came up with it, where I started, and where I'm at now. And then I'll do future videos on particular sections of it. Okay, so first, there are a lot of variables that I'm floating here, and that's, luckily I'm using a Arduino Mega, so I have plenty of memory. If you try and do this on a Nano or anything, or even an Uno, it's just not going to happen. Even with all the crazy variables I have set up, I'm still barely using half of the resources on the board. So, yeah, I built a hexapod previously, and for that I started off with a Nano, and ran into problems really fast as far as memory and all that. Again, because I'm not a C programmer, so I'm sure there are much better ways of doing a lot of what I've done here. Anyway, that being said, a lot of this also is because of development, I should say. When the final day comes, when this is, quote unquote production code, I'll remove a lot of this. For example, I have several debug variables, and even to plot to the serial plotter variables for testing and such. Those will all go away. Same thing with all this testing. I have a loop set up further down that'll run through and check what I'm looking to test. In this case, it's all the movement. I have a separate file where when I first started developing the electronics, it just tested each component, each sensor, each motor, etc. But that's a whole nother story. I'll probably do a video on that along with calibrating the motors, because that's a really, really important step before you can even get to developing your robot. I've seen a lot of videos on the Spot Micro project where a lot of guys have issues with, and then it's an exciting thing to do. So you want to immediately get the motors plugged in and get it operating and see the leg move. But if you try to do that too fast, you'll miss steps or not realize you're doing things. And I've seen a lot of these videos where they have jitter problems or erratic behavior of the motors, etc. That's mostly due to the electronics side, but a lot of it can be come down to the coding as well, and the calibration of the motors, etc. So there's a lot of setup before you can get into coding, I have found. All right, I digress. Let's go back to the software. So yes, this first big block, I'm not going to go through it. I'll go through quickly. Like I said, there's a bunch of variables for my test routines. Then I have a bunch of active variables for each piece of hardware so that I can turn things on and off. Again, this is mostly for development. When I finally decide what software I'm going to keep, what hardware I'm going to keep, then I'll do that. So there's for the motors I can turn on and off, the PS2 I can turn on and off, etc. And then you can see here two of the sensors that I'm still playing with are still in test and pending. Anyway, moving on. So I've also created a include file that contains all of my motor parameters or variables. Okay, again, global variables, so yes, it takes up some memory, but this is the way that I've chosen to do it for now. So basically what goes on in here is you could set the number of servos and number of legs, and this is kind of left over from my hexapod project. But I suppose it could still be applicable if you wanted to, if you didn't have coax motors, for example. And then I just assign, relative names to each servo motor to make it easier to reference, and then to each leg to make it easier to reference. And then I create a bunch of arrays which hold variables for the array of servos. Okay, that includes the limits, min and max, their home positions, the setup, which is the pin number on the PWM board, etc. And then I even have some bone measurements in here, but that's for kinematics, which I've not ventured too far into. Okay, going back to the main program. So I include that file, and then I include all the supporting libraries for the hardware. Okay, then we go in to set up each piece of hardware or whatever other variables I need. In this case, here's the PWM controller, then the OLED display, the onboard LED, the buzzer, the RGB LEDs, etc., etc., etc. So we won't go through all that. That's all the hardware setup and various variables that I use for the hardware. And then this block here is the scariest and ugliest because it's a whole lot of variables that I use for all the movements that I've programmed. So those two most of them probably don't even have to be globals, but as you're developing, you say, oh, hell, I need a variable to do this, and then you just shove it up here for convenience, but yeah, at the end of it all, it turns into a mess, so not the greatest of programming. But you will see that I have good programming ethics. I mean, my code is so well spaced and tabbed almost to an OCD level, but you'll see very few comments, so give and take. If you guys are looking to use the software or like it in any way, then I'll probably go through and add some more commenting, but right now there's not much of anything, so you'll have to rely on these videos, I suppose. Okay, that all being said, let's go on here. So this is just a bitmap that shows onto the OLED screen, and then I had to prototype a couple of functions because they're used in a class that I have defined here, which is defined before these functions down in my code, so I just had to create a couple of prototype functions there. And again, this is all new to me, so I had to learn what this was and why I was getting an error on these two functions and why I had to create a prototype and all that. So if you have issues with functions not firing for some reason, or it says the function can't be found, I believe, then you'll realize because you need a prototype created, or you have to move your whole function in the code up to this spot, which I didn't want to do because, again, I'm very anal OCD about my code structure, let's say. Okay, moving on. So then I have, this is going to be very important, a class for the servos. So what I didn't mention is the main reason why I want to give this overview is because a couple of you have asked, how am I managing to run so much hardware and all these motors without problem? And that really all comes down to the whole idea of state machines, which again is new to me because being a web developer, PHP, we don't have such a thing. It's linear programming. There's no wait states and none of that fun stuff. So this is a whole new world when it came to that. But I quickly learned and understood how these state machines work. And what I've seen a lot of people do is you create one state machine and fire everything based on that. And I didn't like that idea. So what I decided to do is for each piece of hardware, pretty much, I have a state machine set up for itself. So that way I can adjust the timing of each. So let's say I have a state machine for my motors, each individual motor, actually, the class creates that. And then I have a state machine for like my battery check. The motors has to run, every 20 milliseconds. The battery check can run every minute if I wanted to, right? So you really need that flexibility to assign different times to different state machines. So that being said, you'll see going through my hardware setups and variables, most of them will have their own interval and update times. Okay, this one's for the RGB LEDs, which runs every 30 milliseconds. And then the PIR sensor has its own. The ultrasonic sensor has its own. So this way I can adjust the times as I wish. Okay, the MPU has its own, etc. Same with the PS2 controllers, same with my serial command script. And some of them aren't necessarily hardware. Like the serial commands is just a script that I run so that I can type commands into the keyboard. It has nothing to do with hardware or sensors, but I still have its own state machine. The amperage monitor, so you can see here, it's running a whole lot slower than everything else because I don't need to check the amperage that often. Same with the battery monitor. Okay? So that being said, if we go down the code further, so here's the class that establishes each motor with its own object. And here it instantiates each of those objects. And this we'll probably do a whole video on, because that was a really tricky part of this whole project. Because when it comes to setting objects around a class that you've included or a library that you've included, it's pretty difficult. You have to actually pass that in as a reference, which you can see I'm doing here, and then connect to it that way. So yeah, I'll do a whole separate video on the whole motor control. But anyhow, if we go down, we'll skip the setup for now. Most of you understand what goes on in there. But here in the loop, okay, so right away I'm looping, and I'm firing an update on every one of the servo objects, okay? But inside this update, it's checking for the interval for the motors, which really is the speed, as again, most of you probably know if you have experience with servos. And that is obviously a variable, because I can adjust the speed of the motors. So that one's not the really important state machine to go over. So what I do down here now, where I say check state machines, first I check if that piece of hardware is active. If it is, then I check its state machine. In particular, its own state machine. Like I explained, each piece of hardware has its own state machine. And then if it's active and the state machine is ready to fire again, then it fires that function which handles that piece of hardware. Okay? Now that works with almost all of this. I've had very few things cause any kind of interruption with each other. The only two tricky ones that I'm running into is the MPU unit, because that's something that, when you're using it, it's got to be running all the time pretty much. And the OLED, and that's kind of my fault with sloppy coding, is I'm writing to that screen in the middle of a walking routine, for example, and that's not a good idea. So that slows it down. So really, if I refactored my code a little bit and only wrote things to the OLED when the robot was at a standstill and not moving, then it wouldn't be a problem at all, because that does make the movement a little bit slower in the motors. But everything else works great. And again, adjusting the times for each one of these things could very much solve any of these little interruption problems that you may find when you use multiple state machines. Okay, so yeah, it checks if the hardware is active, and then it runs its function. Checks the serial, runs its function. Checks RGB, runs its function. Okay, and then within these functions, like I said, for the PS2, for example, it's going to check what button's being pressed and take action on that, etc., or check if any are being pressed, looping it for the interval each time. And then at the end of this function, I reset the last update. So it'll loop during that time for that, just through that one function. All right, hope that makes a lot of sense to you. If it doesn't, feel free to ask questions in the comments, and I'll be releasing my GitHub so that you guys can have this code too to do what you want with it. I mean, understand that it wasn't written for public consumption, so good luck is all I can say. But I welcome any questions and be happy to help or explain any piece of the code. Okay, so yeah, there's a bunch of state machines that fire here, as you can see. I mean, if we were to count them, 1, 2, 3, 4, 5, 6, 7, 8, and then one for my movements. So yeah, 9 state machines are firing if I have all of the hardware active, obviously. Okay, then I just have a little test routine, and that's the end of my loop. So from here down, it's all functions. And I'm going to cut this video short because it's already 14 minutes long. But to be honest with you, we're at 1,100 lines of code. This file is close to 6,000 lines of code. So yes, I've written a lot of code for it. A couple of these functions are lifted off the internet. Like you could see some like rainbow and color wipe. Actually, color wipe paired is mine, but color wipe. So these all come from Adafruit's NeoPixel library. What else? I think the MPU, the MPU, I took a couple of functions from the internet. Other than that, it's mostly my code. I have all the functions collapsed, so we can just run through this quick, and then we'll call this video done for now. So here are my check functions, which are pretty much the state machine functions, right? This PS2 one is probably one of the largest. Hell, it's probably 1,000 lines of code itself. Let's see. Yep, just about 700 lines. And, you know, a lot of this is, you'll see a lot of print statements in here for my debugging. Remember I said that a lot of this code can come out. So there is a lot of debug code that takes up a lot of lines. And plus, again, I'm pretty anal about how I write code. You'll rarely see me, you know, do an if statement without a bracket there and just doing my one action. Honestly, that annoys me when I see that, and not to get into programming issues, but that's all well and good for the first person who wrote that line of code. Like, oh, cool, I'm done. I wrote that line of code, but now when the next person comes along and needs to do something else there, then I have to go through this effort of doing that and adding my closing bracket, and that's just not fair. I understand it's a shortcut, but, you know, so here I did it once. Okay, just to illustrate what I'm talking about, and then I'll call this video done. So, yeah, this is great. I mean, it saves you a little bit of time as the original coder, especially if you do it like that, and it's one line of code, wonderful. But again, if I or you or some other developer comes back and we need to fire 2 commands here or 2 lines of code, yeah, the only choice we have now is to take the time to go ahead and reformat your code and then do our command here. I just don't think that's fair. I understand it's a shortcut, but not my style. But again, you can see I've done it here. Anyway, I digress again. So yeah, this PS2 function does a lot of checking for a lot of the buttons. I've taken it 3-4 steps in. When you hit the select button, you have a whole new set of buttons again. So, and if you hold down one and do something else with the other, there's a lot going on with my remote. Again, a lot of that's probably development. I'll probably scrap a lot of it at the end of it all. But I do have a diagram to go along with the PS2 controller to show what control does what. Okay, so then here are the other state machines that just do all of the sensor checks and the battery checking and such. And then I have a bunch of operational functions, which pretty much initiate the servers or detach them all. I have my own ramp function that I wrote, which works pretty nicely. And then just, you know, sends them home, sets them all to stop, or stop everything in an emergency kind of thing, setting the speed and such. And then I have a whole bunch of move functions. Most of these use a couple of, let's call them sequencing functions that I wrote, which let you either do kind of control sweeping of a motor, or you can control position to position of a motor, and it lets you do all kinds of stuff interpolated within those functions. This first one is for the MPU unit, just to keep it level set axis. I'm still sort of playing with that. It's not integrated into any of the movements yet. And then I just have a little function called run demo, which basically runs through all the movements that it can make. And then, yeah, so some are static movements, which just move to a position, like this bunch here, to kneel, lay, crouch, sit, and stay. And then I have a bunch which are pretty generic and kind of sort of kinematic, but not mathematical, let's say. And then I just have a bunch of movements. Those are all kinematic, but here, step trot, step forward, look left, look right, etc., etc. And then here are my sequencing functions, which I came up with 3 different ways of sequencing movement, which, again, I'll go through this in another video. I keep saying I'm going to end this short, but we're pushing. Let's see if we can get it under 20 minutes. I think I'm done here. And then a fistful of general functions, again, for development. So limit target and limit speed. Those are 2 to ensure that I never tell the servo to go, 1,001 degrees kind of thing. Eventually, when the code is tight, that could be removed kind of stuff. So same here is a step complete. And then these are pretty useful. And I suggest anybody writing this kind of software does some functions like this, where you can just say, so now I can refer to any leg that I want pretty quick and easy by just asking, is it a front leg, which will tell me if it's a front or back, left, which will tell me if it's a left or right, rear, which will tell me if it's a rear, or actually, this is kind of silly, right? I don't really need both of those. And then is it a femur, is it a tibia, and if not, it's a coax. So those are very useful. Okay, and then degrees to PWM and PWM to degrees. Right now, I'm not using those. I'm really driving my servers based on the PWM logic and not going anywhere near degrees. It's really not worth translating back and forth unless, yes, once I get into kinematics, then that's going to be needed. But right now, I don't use those two functions, but they're pretty handy anyhow. Okay, then we have my print command, which really just reads the data coming in from the serial monitor and then fires off commands accordingly. And they're pretty simple. They're just, set the speed, 1, 2, 3, etc. And then the LED functions and some tone functions for the buzzer. That's it. So yeah, let's call this quit. I'm over 20 minutes. And I think I will do the next video. If you guys like this video format and want to see more of the code description, I'll do one on the motors and the class that drives them, because that's pretty much the meat and potatoes of this. And then at the same time, I'll probably, demonstrate the sequencing functions that I came up with and what all this mess is about. Because theoretically, probably when it comes down to it, I'll either get rid of all of this and go full kinematics, or I'll choose the best method that I've come up with, because I really, like I said, came up with 3 sequencing methods, more or less, though they each can do slightly different things. So, needless to say, this software is very much in development. All right, thanks for watching, and like, share, and subscribe.